Today's talk is really about streaming big data and the notion of streaming data into your data lake. And the thing about streaming data is it is awesome, right? You have all this capability, you have the ability to not run giant batch jobs, and I'm here to really talk about a little bit about how streaming data is great until it isn't, right? So what are the big things, what are the advantages of streaming data into a lake or big data or streaming data at all? Right? You get continual updates, like real time. Like if you need near real time kind of capability or near time capability where you're trying to pick up click streams and take actions on it, streaming's amazing. You can get fan out. So you can actually send data to multiple sources using streaming at the same time. You don't have to run like batch jobs to talk to the different, and you don't have to make multiple remote web calls, right? You can stream the data and they can listen for it. There's no massive full data set processing required. If you get a terabyte of data an hour or a couple gig an hour or whatever, and you need to process it, if you're streaming it, you've only got those little bits. So it's great. And it's practically unlimited scale. You can fan out your streams to be able to handle quite a large amount of data. One of the places I worked, we were doing, I don't know, a couple million messages a second. Yeah, it was a couple million messages a second, the way we had it set up. And this works really well for event tracking and logging. And the other thing it's really good at, so one of the questions is, how is this data going to be applied? If the changes or the data you're streaming are idempotent, meaning you can apply the changes in any order, or you can apply the same change over and over, then and get the same results, then that works out really well. Where doesn't it work? It doesn't work when the things that are bad about it are that order isn't guaranteed. So you don't know that the messages will actually arrive in the consumer's data store or consumer's process in the order that they were sent. And systems at scale even have to kind of make this mandatory so that they can have the high availability, right? So duplicate data is possible. The way the consumers work and the way the queuing works and failover, it's definitely possible to get duplicate data. And that's something that doesn't happen with other kinds of data handling. Blown consumer operations in a stream can be really hard to recover. Now, with things like Kafka, where some of the data will hang around for a while and you can go back and replay part of it, it works. But if you're streaming using a messaging system or you pick the wrong pattern and data's dropped on the floor by the consumer, you may not be able to go back and get it. And actually, depending on the way the fan out works, that still may be hard even on a good system. Fan out failure is hard to reconcile. So you can have a data source coming in, right? And it goes to 2 or 3 different systems, and some of those systems work and some don't. And then depending on the way your streams and your handling and your syncs are set up, right? It may be that third source, it's going to be hard to bring it in sync, reconcile it with the other 2 sources. The other thing is there's no notion of a data set. So if you had a data set that represented the month's blah, 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 when you're streaming, you don't really have a notion that that's the month blah, 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 or that the whole month arrived. There's no notion of a giant envelope around that in a lot of cases. You have to build your own, and that can be a fair amount of work. So really, streaming data can make reliable consumption hard. It accelerates a lot of things. It makes a lot of things possible, but consumption can be difficult. And we're going to walk through a little bit of why that might be. So we have this stream here, and it's actually 6 records or 6 messages in this stream, 6 events, and they're like XYZ, ABC, right? And the way the system gets put together, it's actually, I'm going to use Kafka as an example, but any sharded system, right? So one of the nice things about Kafka is orders guaranteed within a shard. But if I had XYZ, ABC, and they come in, X, Y, and Z could end up in one shard, and A, B, and C end up in a different shard. And when those are processed, depending on the way the consumers for the shards work out, they may show up in different orders. So here I've got 2 different systems, System 1 and System 2, that are really listening on the same stream. They're picking up the same events. And one of them, because of the way the consumer per shard worked out, one of them ended up picking this up in XAY, right? Because it picked up the second shard first message before the first shard's second message. And the other one actually ended up as XY and then A, right? So it picked up the first 2 in one shard. Maybe the consumer's a little slow on the other shard, and so it comes along and picks up the other. So these 2 data stores for some period of time will not be in sync. And that may be okay, but it's something to be aware of, the way this works. So what are the ideal use cases for this if we start taking this into account, along with the streaming pros and cons before? If the records have meaning independently of each other. The data is already naturally a stream of events, and some is and some isn't, but that will probably work. Flow logs are a really good example. Certain kinds of log files, they're amazing for streaming because in a lot of cases the records themselves are independent of each other. There's not an additive thing. You need all the records to do an analysis, but the records are independent. The data load could be too large to batch. We could have a really large amount of data and you don't want to stand up giant batch machines to do these big processing that has to happen in a certain window. And another example where streaming is really nice is a serverless environment. If you're in the cloud and you've got all functions or lambdas or whatever, the fact that you only have, you need to do a lot of processing, but none of the processing is gigantic means you can run these smaller serverless environments where you have high fan out. So what are lousy use cases, in my opinion? Anything that's doing data replication via CDC, and we'd use this for this all the time. But I would actually argue that if you're doing change data capture and you're applying changes to another data store, you'll end up with some problems with that. And I'll talk about it in a minute. If order is required because the originating system can't apply the right kind of sequencing or other thing to it, sequence number or other identifiers to it, I've seen 2 places so far where we were putting these in general ledgers or ledger systems, and we streamed data and it didn't come in order, and it was bad news. It was like delete. We had to create an account, make a deposit, make a withdrawal, delete an account. And we had situations where the delete showed up before the create. There was no account. It threw an error because why would you delete something that didn't exist? Then a create would come along. It would get populated. And then we'd have an account open with no money in it. But we did because the delete message had actually thrown an error. Another one that's a problem with streaming is if a block of data or a block of stream of messages or events should only appear when they're all available. So that's a kind of a notion of a transaction, right? Like if you need any kind of transaction integrity, streaming really isn't a good way to do that. If I needed these 7 events to always show up in a financial system or in some other system, and it turns out that they could be delayed or it would look weird like there's a partial something that happened. Some cases that's okay, especially for humans. They can see stuff is starting to happen, but that may not work for systems or for exports, for doing partner interchange, those kinds of things. Another one is where your sync is a file or a blob store. So if you're in the cloud and you're streaming, really you're going to be micro batching, right? You're going to take those streams, you're going to take a bunch of messages, you're going to put them together, and then you're basically going to build a mini batch out of it. And that's cool, but you're really not completely streaming. And it's because the sync doesn't work in a streaming fashion, the place the data is going to land. So I'm going to show you 2 other examples and try and keep this under 10 minutes. I've got 2 batches, 2 data sets. They came in from third parties maybe. I got to do ETL on them and then stream them into my lake, right? And here I've got 2, A, B, and C, and X, Y, and Z. For purposes of illustration, I put them in 2 different shards like in a Kafka system. When they end up in the consumer, the data just starts showing up. There's no notion of a beginning and end, right? Because I've really got this stream of ABC, XYZ, and I have no idea how those 2 are going to be commingled because they were fed into the stream, they were fed into the eventing system at the same time. So in data, their data could be commingled, which is not a big deal. But because there's no begin and end, and because they could be out of order, begin and end doesn't make sense, the consumer won't actually know when that data set ABC is done or XYZ is done, right? Like you could maybe send a counter that tells you how many messages are coming from that data set and then put a data set identifier in it. But even that's kind of weird because the counter can show up after the data set starts appearing. Sometimes you'll get like an N before the beginning. So it's not doable. It's just like you got to start thinking about, hey, if I this notion of completeness, I need to know when all of the tax records were generated so we could file the 941 for employees, right, or whatever. Then that becomes a little bit harder with streaming, right, because you don't know when they're all there unless somehow you get a count out of band somehow. So in this case, the problem is I need the data to be put into a separate system or data store in order. And so the problem there is these machines, this data will show up partially because I have different consumers, right? Running each on different shards, or I could have multiple consumers on a single stream and they fall out of order because one's faster than the other. In that case, a lot of times people will end up having to build a serialization sink. They pull the data in and they look at the sequence numbers, and as they fill out with sequence numbers with no gaps, they start sending those things in a serialized fashion into the next system. And whenever there's a gap, they have to wait around. and if that gap never shows up because a message is lost somehow, then that thing will just lock up. And I've seen that too a couple times. So those were basically the two of the examples, right? One of them was data completeness, like how do we figure out a way to know all the data that's required to process is there? And another one was how do we make order, and how do we make it where some system that's susceptible to time problems can actually work. All right, so that's it for me. I hope this was good.